when we design a model, this is the data set. This is the data set. We have some dependent variable x1, we have dependent variable x2, we have dependent variable x3, and finally we have some target variable y. This x1, x2 and xt are called not dependent, sorry, it is independent variables. Independent variable, and y is called dependent variable. Dependent variable. Actually x1, x2, x3 determines y, or we can also say that these three functionally determines y, like this, as we have learned in TBMS. Now based on the type of the data, if we have some continuous data like 6, 3, 2, then some value 7, 3, 4, 5, some value 6, this type of value are called numerical value, and this data set is said to be numerical data set. On the other hand, if your data have some categorical value, like say text, or maybe numeric, or the text, for time being you assume that here we have some characters ABC, E, F, G, M, N, P, say this is x1, this is x2, and this is y, and we have some values like 1, 0, something like this, 1, 1, this. So in this case, where data is not necessarily numeric, it is alphanumeric, and moreover it is descriptive data rather than some quantitative data, then this data set is called what? Categorical data. Categorical data. Now based on the type of data, we can have some regression model. Two types of models we have: regression, another is classification. These two types of models we have. In very basic term, if your data set is numerical data, if your data set is a numerical data, we go for regression. If your data set is categorical, then we use for classification. But more precisely, the question, what type of model is used for a given data set, it depends upon primarily one factor, that is called what is the type of target variable. Say here y is the target variable, and which takes the numerical value. If this is so, then we should go for numerical data, or also we can say continuous data, then we should go for regression model. If your target variable is not numerical, rather it is say categorical, categorical, then we should go for classification. Here in this case, this data point belongs to positive, say that positive category, this is belongs to negative category, this belongs to positive category, this belongs to negative category, like this. If the data is numerical and the target variable is also numeric, then we should go for regression model. Otherwise, if it is categorical, target variable is categorical, then we should go for classification model. Apart from that, if the data or target variable is numeric, but we wanted to use the regression model, but regression model, although this regression model, we will be using the regression model this on numeric data, what target variable is like, for example, if say this is the marks, then instead of 76 we write say 70. This 7 is considered as a pass mark, this is a fail mark. Then instead of 7 we wanted to represent 7 as pass and 6 as fail, say. In this case, data is numeric, but target is also numeric, but we wanted to represent in the form of categorical. We don't want to get we don't want to predict if the marks of x1 is 6, x2 is 3, then target value is 7. Instead of that, we wanted to tell that the data point is predicted as pass, like this. Or we wanted to say data point is predicted as fail. That means here also, although the data everything is numeric, it is defined as a categorical data. The endpoint or the target variable is considered as a categorical classification or categories. In that case, we should go for regression model, but not the linear regression. Rather, we should go for logical regression model or logistic regression, not logical, logistic regression model. Logistic regression model. So after designing the model, once the model is there, we have the data set, we have a model, we feed the data set into the model, and we get the performance or we get the results. Once results are obtained, what we are supposed to do, we need to verify whether the results are useful or not. Useful or not useful. So in order to find whether these results are useful or not, we have to use performance, we have to evaluate the performance, or we have to evaluate the performance of the model. And to evaluate the performance of the model, we use performance matrix. Performance matrix. So based on the type of the model we have, if we have a regression model, then we should go for evaluating the cost of computation or cost of the model, mean square error model or root mean square error model. We should go for R square value, and we should go for adjusted R square value. On the other hand, if we use a classification model, then we should go for primarily the confusion matrix. We should also evaluate precision precision, we should evaluate recall, we should evaluate ROC curve, we should evaluate area under curve, right? So these are performance parameters which is computed for classification model. These are performance parameters which is used for regression model. Okay, we have seen the classification model, and we also have seen the regression model. And in order to evaluate the performance, of regression model, the cost, root mean square, and R square and adjusted R square, this value we have examined. Now let us suppose that we wanted to form a confusion matrix, and this is the most basic and important performance matrix for classification model. For explanation of, to understand the concept of classification or confusion matrix for classification model, let us take one example. Suppose that we have a data set, and this data set has some input or independent variables, and also it has, say, x1 is the independent variable, x2 is the independent variable, and this is the y which is target. We are not considering all the data, whatever it is, but finally we know that the final result, we know that this data point, the target is 1, this is 1, this is 0, this is 0, this is also 1, let us say, and one more point, let us say this is also 0. This is called the target values. What does this mean? It is said that in the given data set, this point is resulting 1, that is to positive class. This point evaluates to positive class. This point belongs to negative class. This is also negative, this is positive, and this is negative. Based on the given data, what we will do, suppose that we are using a classification model, any classification model, like say decision tree, maybe naive Bayes classification model, any classification model, maybe naive Bayes, maybe support vector machine, maybe decision tree, any of the machines we have selected. In order to implement the model, in order to you apply this model to this data set, we will divide in this, we will consider all the data set as a, we will divide the data set into 80% 20% ratio, and this 80% we use as a training data set, and this 20% we will be taking as a testing data set. What is the speciality of the testing data set? In the testing data set, we have the value of target variable, and we also compute the predicted value of the target variable y hat. This is a testing data set, test data. In the test data, there are 1, 2, 3, 4, 5, 6 data points, and we have tested this model, classification model, any one of the classification model we have considered, say naive Bayes, and we have performed the model, we have used the model, we have applied the model on the testing data set, and we have found that this is evaluated to 1, this is evaluated to 0, this is evaluated to 1, this is evaluated to 0, this is evaluated to 1, this is evaluated to 0, right? Out of that you can see this was 1 and it is predicted as 1. This is correct. This was 1 but it is predicted as 0, so it is incorrect. This was 0 and predicted as 1. This is also incorrect. This is predicted correctly. This is predicted correctly. This is predicted correctly. Right? Now, based on this data we have received or we have evaluated the predicted value, we have to form the confusion matrix. We have to form the confusion matrix. It's a 2 by 2 matrix, and this is this coordinate, this cell represents true positive values, total number of true positive values. This represents total number of true negative values. Let us count true positive. What do you mean by true positive? That means it was true and evaluated as 2. This is called true positive value. This was true, evaluated as true. This is called true positive value, right? So this was true, this was true. This was not evaluated as true. So true positive is 1 and 2. This value will come here. On the other hand, here the true negative value, how we will calculate the true negative value? True negative, this was negative but it was evaluated as 1. It's not true. So here this one negative, it was evaluated as negative, so it is true negative. True negative. Similarly, this was 0 and it was evaluated as 0. This is true negative. True negative. True negative. So true negative is also 2. What it will go, we can mark it as this is 1, this is 1, this is okay. So that's not important. This is, it represents positive class, it represents negative class, it represents positive class, it is a negative class, this way, right? Okay, so what this value will represent, what this cell will represent, and what this cell will represent? This cell will represent false positive. False positive. Now false positive means this was 1 but represented as 0. I mean it is predicted as 0. That is why it is falsely evaluated as 0. This is, and is there anyone, this one, but this was correctly evaluated. So false positive is 1. And this one represents false negative. False negative. False negative means 0 evaluated as false. I mean 0 evaluated as 1 means it was false but it was evaluated as true. So this is falsely evaluated as negative. This is called false negative, and there is only one false negative value. Right? Do you understand? Hope you understand. Anyways, so now what happened here? Actually, if we consider these two values, these values are need to be high. TP, true positive, we should have true positive and true negative should be high. Should be high. And false positive and false negative should be low. This is called the error in the model, because they are falsely detected, and this error is called type 1 error, and this one is called type 2 error. Type 2 error. Moreover, if we add this value, f is 2 plus 1 equals to 3. 2 plus 1 equals to 3. This value gives total predicted predicted positive class. Total predicted positive class, you count here 1, 2, 3. This is total predicted 3. This value will come. 2 plus 1 is 3. This side will get total predicted value. Similarly, 2 plus 1 equals to 3. These three represent total predicted negative. Predicted negative is 1, 2 and 3. See, 1, 2 and 3. This is correctly coming. So if we add this side, if you add this side, then 2 plus 1 is 3. 2 plus 1 is 3. This 3 gives the actual positive class. 1, 2, 3. And this one gives actual negative class. Negative class actual 1, 2, 3. 1, 2, 3. So that is why it is said that this way is predicted. In the book you will get this is as predicted without any explanation, and this one will say actual. Actually the meaning is, if we count this way we will get the predicted values, if you count this way we will get the actual values. And 1 represents the, this side 1 represents the positive class, 0 represents the negative class. And since it has only 2 classes, positive and negative classes, that's why this is called a binary classification problem. Right? It is called a binary classification problem. Now from the given confusion matrix, if you compute the confusion matrix, from the confusion matrix you can calculate few things. These are called, say, precision. You can calculate precision, you can calculate recall, you can calculate accuracy. And here in both the precision and recall, the things TP will come above and TP will come here also. TP will come here also. This is the way how you can remember this formula. For the precision, this is P, right? That's why you go to this column, this cell. FP plus FP will come here. And recall is from, you have to consider for precision recall, you have to consider these two cells, this cell and this cell. One already used FP, so one is left, that is false negative, so false negative will come here. And if I do that, true positive is 3 and true positive plus false positive is 3. This is equals to 1, 3 by 3. Because of the data only we are getting not that proper results, 1. And accuracy, it is given by true positive plus true negative divided by all the values, that is total number of records, we can say 6. This is also 1. So if it is 1, 1, 1, it's not, it is showing that it is very perfect machine, very perfect, but is not necessarily true. It is because of, it may happen because of two things. One is the selection of wrong model. Second one, maybe there is no validity of the data given here. It is becoming because of the improper validation of the data which we have considered for computation. So these out of these different values, I told you that false positive, the value in the false positive field, it represents the type 1 error. Type 1 error. And the value in the false negative field, it indicates type 2 error. Type 2 error, right? And sometimes based on the problem, what is important, we should emphasize either on false positive or on false negative. That means based on the problem we decide whether we decide that we should have lowest or as low as possible false positive values, or other problem you can say we should have lowest or as low as possible false negative values. For example, suppose that we have a problem that data set we have to identify whether a patient is affected by cancer or not. Cancer, if why, then he is affected by cancer. If it is not, then it is not affected by cancer. Suppose that in one, this is the actual value and we have predicted value as why he has actually cancer, but he is detected by the model as not having cancer, like this. If it happens, this is means it is what? It is false. It is false negative. It is false negative. False negative. It is false negative, right? That means he has cancer, but it is detected as no cancer. In this case, this false negative will be more. False negative is equals to 1 here, and true negative is, say, true negative is equals to 0. Suppose false negative is 1. So if false negative is 1, then false negative is in type 2 error. Type 2 error is more. If false negative is 1, that means if false negative is more, then type 2 error is more. Is more. But then we have to think, suppose one person has cancer, but he has detected as no cancer, that means he will not be diagnosed as a cancer patient and he will be relieved. If it happens after a few days, the patient may die. It is very severe for the patient because the patient will not get any treatment. By the time it is been recognized, he is already dead. That's why it is said that in such type of problem, this type 2 error is very severe. Very severe. So we should try to minimize the type 2 error. We should minimize, we must have to minimize, you should always try to minimize the type 2 error. Because if we suppose that one patient is not having cancer but detected as cancer, it is okay, because in that case, in the later stage of the diagnosis, he will be evaluated as not infected by cancer. So it is okay. It is okay because he will start, he will go for further treatment or further diagnosis, then he will be detected. But in this case, if it is having the cancer, not detected the cancer, then it is a severe issue. That's why this false negative in this type of problem should be minimized. And the false negative is determined by which value, which parameter? Recall. So then in that case, recall is much more important than precision, right? Recall is much more important than precision. Similarly, for the problem where type 1 error is more severe, that is, we should minimize the type 1 error, then we should calculate the precision. And when both of them are equally important, then we should go for accuracy, right? We should go for accuracy. Is that okay?